What I wanted to talk to you about is the big impact of confidential computing and what will be sort of the big business impact I think this is going to have and where I think all of this is going. The best security solutions were always enablers. They always enabled us to do something that we couldn't do without them. Probably 10, 15 years ago, none of us would go into an airport or go into a Starbucks and use the Wi-Fi there to log into our bank account or to read our corporate email. This has obviously completely changed. We're all happy to use the Wi-Fi here in the conference or in an airport or in a Starbucks to log into our corporate email, to log into our bank account. And it was all enabled because of security, because all the data is completely encrypted between your device all the way to the website. The same thing happened with the firewall. I'm still sort of old enough to remember, in the late 90s, organizations couldn't connect their networks to the internet. Large banks, they were completely siloed from the internet. And the big shift that happened with the firewall is these organizations were able to take their internal networks and connect them to the internet for the first time, which unlocked an insane amount of value for the industry. And the next big enabler is confidential computing. I'll go deeper into explaining what I mean, but that is the next big shift that's happening, the next big security enabler that essentially allows us to take any piece of data or any workload and run it in any environment with complete security and privacy. When we look at the workloads today, only about half of workloads are in the public cloud. When you go into a regulated G2000, the situation is even worse. You go into a large bank, you go into an oil and gas company, you go into an insurance company. What you usually see is that about 15% of workloads they were able to move those to the cloud. There are about 10% of workloads they will probably never move to the cloud. And then 70 to 80% of workloads are workloads that they want to move to the cloud, but they're essentially not moving. And every time a survey comes out on why are these workloads not moving, there's a huge amount of benefit in the cloud. There's services that only exist in the cloud, like Snowflake, like Datadog. There's a bunch of the ability to scale in the cloud is obviously extremely helpful. So why is it not moving? The answer always comes back as security and privacy. And it's sort of weird on why is security and privacy blocking these cloud transformations? And it's even weirder because the cloud, obviously any cloud vendor has better security personnel, access to better security tools than any individual company, right? So why is security and privacy blocking these transformations? It's happening because the cloud is essentially somebody else's infrastructure. And the challenge these organizations are running into is if somebody else is managing my infrastructure, do I give up control? Does that third party have access to everything I do on top of that infrastructure? Can a government come in to my cloud vendor and ask to get access to my data? Can somebody else running on that same server, some other company, are they able to eventually get access to my data and my workloads? And confidential computing is what essentially solves that problem. We've seen that big shift happening in the industry where essentially all the CPU vendors, the GPU vendors with NVIDIA are all baking in confidential computing into their chipsets. And essentially all the clouds are adding support for confidential computing as well. And the reason this is happening is to enable these transformations, to enable you to take your data and your code and run it in any environment without having to worry about who has access to your data, who has access to your workloads. But the thing is, every time a shift like this happened on the hardware side, on the infrastructure side, you needed a software stack on top of it to enable it. And we've seen that in the past. We've seen that with the CPU itself and Microsoft building the operating system to give as a software stack on top of the CPU to give us access to the CPU. And we've actually seen the same with VMware with virtualization. Virtualization was part of the operating system, was part of the CPU. What VMware did was build a software stack to make it super simple to virtualize anything. And that essentially unlocked virtualization, which was to some extent the birth of the public cloud. We wouldn't have a public cloud without virtualization, the virtualization that VMware unlocked. And this is exactly what we need for confidential computing. We essentially need a unified confidential computing platform that offers you the ability to run on any infrastructure. Doesn't matter what's the underlying CPU on top of it and which cloud you're running on. Something that allows you to run any application this way. Not just protecting the keys, not just protecting the database. Essentially running any application this way because even if you protect the database, there's an application built on top of that database, and the data gets there too. We need to protect that piece as well. We need to protect the data not just in use, we need to protect the data regardless of where the data is. And one of the most amazing things about confidential computing, solving the data in use problem, is that data is born in use. Data is created when the application is up and running, and if we have a way to protect data in use, we can automatically protect the data coming out of the application to go to the file system, to go to the network. So you can protect data in any state. And the last thing, to just tie it all together, are trust controls. How do you put controls on top of all of it to make sure that the way applications share data across different infrastructures or on the same infrastructure is completely secure? So only the applications that need access to the data have the access to the data when they need it, and the data that they need to have access to. And that's where the attestation piece comes into play. What attestation essentially does is it gives identity to applications. So we can create policies in terms of what application can access what data and which applications can talk to one another. The same thing that essentially happened on the user side can now happen on the application side. And this is exactly what we do at Anjuna. We essentially made confidential computing as simple as one command line. You can kind of see here, essentially Anjuna run application, and you can take any application, any workload, and run it in any environment with complete security and privacy. And we have the trust controls on top of it to tie it all together, to make sure that data is only shared with the applications that need access to the data when they need that access. I'm gonna go quickly through this, but today we support Microsoft and AWS with Nitro Enclaves. We announced as part of this conference support for AMD SCV on top of Azure. Next for us would be AMD SCV on top of Google Cloud and on top of AWS, and obviously supporting TDX as it comes out, and the confidential computing GPUs from NVIDIA. Let me talk to you about just a couple of use cases before I free all guys up to go to lunch. But the high-level use case that we see, as I mentioned, is cloud transformation, is moving things to the cloud that you couldn't move without confidential computing, protecting secrets, protecting data, and use cases around multi-party computation. How do you create the right policies and the right protection to allow organizations to share data between one another in a protected way? But let me go deeper into two of them, which I think are super interesting. One of our customers is a top 5 European bank. And the issue that they had is they have a core banking application running on a mainframe. And they created a mobile user experience for their customers. They have about 50 million customers using that mobile experience. And what happened is that the mainframe became a bottleneck. Basically, if you have 50 million people coming in at the same time to view their bank account, think after payday, everybody's coming in to check their bank account. Everything has to go to the mainframe, and the mainframe becomes a bottleneck. And they essentially had two options. One option was to scale the mainframe, which was a $100 million project for them that nobody wants to scale a mainframe today. The other option that they had was to put a caching mechanism in front of the mainframe. Basically, the first time a user goes to their bank account, the bank account information gets cached. Next time it just comes from the cache. You don't have to go all the way to the mainframe. You do operations, they get cached, and then a few times a day they get synced back to the mainframe. The problem that they ran into, though, is they wanted to put that caching mechanism in the cloud, because that's the right place you want to put it, right? A lot of people coming in after payday, you want to be able to scale it up. At night, nobody comes in, you want to scale it back down. It's just a perfect use case for a cloud, but it got blocked. This is PII data of customers, bank account information, transaction information. Security and privacy wouldn't let them put this in the cloud. And that's exactly where we were able to come in and run it inside of confidential computing, completely protect the data from anyone who might have access to it on the infrastructure, and unblocked this huge migration to the public cloud. And then I think about this use case is once they now have this tool, they're now looking to deploy this across everything they do on top of the public cloud. This is becoming now their new layer for protecting data in the public cloud. The second example I wanted to talk to you about with a large defense agency that we talked to, they started going down the GovCloud path. The problem is that they don't expect their GovCloud to be ready before 2030, and with the legal battle that's actually started happening, it's probably going to be even later than that, but they need access to the cloud now. And essentially they need access because of two reasons. One is scalability. Part of it is essentially an intelligence agencies that collect enormous amounts of data, and they just can't scale their external infrastructure fast enough. They need cloud access. And the other piece is just access to services that only exist in the public cloud. You know, things like Snowflake, things that just don't exist when you run on-prem. But because of the sensitivity of the data, they just couldn't use the commercial cloud, and that's exactly what we enabled for them. Running on top of confidential computing essentially gave them the security and privacy that they needed as a gov cloud to be able to run on the commercial cloud for the first time and unlock all the value in terms of scaling and in terms of access to services that they needed. The last thing I wanted to say is what confidential computing essentially creates is a world of borderless computing. It's beyond just security, it's beyond just securing or encrypting data. Essentially, confidential computing is an enabler that allows you to take any workload and any piece of data and put it in any environment. It means you don't have to think about, which country is it running in, or who manages the infrastructure, who might have access to the infrastructure. Again, cloud migration is a huge use case for us now, but there's use cases on the edge. The edge is even more out there in the world than any server, and there are use cases there. Eventually, where I think this is going is confidential computing is just going to be computing. We're just going to run everything this way, and this will enable us to get there. Thank you.